Good afternoon. Pleasure to meet you once again today. This is Nagarajan. I hope the voice is clear and the video is clear to you. If so, can you please raise your hands? There's a raise hand symbol in reactions. Or you can also type it in the chat box. Okay, good. I think we have seen 4 experiments yesterday. We will continue doing this because our aim is this kind of virtual labs will help the teachers to teach stuff in an activity based mode. More than animation, this is simulation. This is activity based learning. Let us start today with pendulum. Pendulum moves here and there like this. This is basically used in the clocks, but those clocks are now almost not there, except some of the old-fashioned schools or colleges or old schools where these pieces are kept as antique. These clocks are almost not there. How many of you in your house had at least 10 or 20 years back pendulum clocks? If you had pendulum clocks in your house, can you please raise your hands? Or you can type it in the chat box. And we have to give the key to that pendulum clocks every week. And we have to adjust the pendulum length also from time to time. Good, I see one person saying that that person had pendulum clock. Great. Now let me start sharing my screen. I hope my screen is visible. Yes, Ganesh?
Yes, sir. Yes.
Now, this is a pendulum lab. We would like to show first a simple pendulum. As you all know, the pendulum has this origin or the place in which it is centered. Then there is a thread, there is a mass at the end of the pendulum. And this moves because gravity pulls the pendulum down. When we make the pendulum to move, it starts oscillating around this place in a circular fashion. We can now adjust the pendulum's length. So if you see here, if I adjust this knob, the pendulum's length can be adjusted. Then the mass also, I can increase the mass or I can decrease the mass. Right now it is set at 1 kg. I can increase the mass also. Of course, this is Earth. On this Bhumi, you know there is a gravity, and this gravity is fixed except certain exceptional locations in Earth. On Earth, this is fixed. The gravity is different in different planets. The gravity of Earth is different, gravity of Moon is different, gravity of Mars is different. And I can also adjust this friction, because the friction can be because of air resistance, or the friction may be because of the friction happening in this place where it is centered. Now, I am going to make the pendulum to oscillate. So now I am moving this pendulum here. It's almost like 20 degrees I'm moving. I'm releasing the pendulum now. Now it makes oscillations, right? Right now, it assumes no friction, zero friction, okay? So it keeps on oscillating. I can also show that in your slow motion. If I make it in slow motion, I click this button, slow motion. Now it moves to the right, it moves to the left of me. Now let us watch. Now it is moving and it is reaching this rightmost point. At that point, as you know, the potential energy, it reaches this leftmost point or the rightmost point. The potential energy is at the peak. Typically, how we do calculate the potential energy? Potential energy happens because a mass is raised and it is above the ground at some point of time, at some height, right? So typically the formula will be, I think, mgh. So mass into gravity into height. That will be the potential energy. It is at the peak at here. Now it starts moving. When it reaches this point, lowermost point, it also has kinetic energy. Kinetic energy will be the peak here. Here the kinetic energy is low. Here the kinetic energy is peak. Again it goes to low. So this is how the pendulum keeps oscillating. Now let me make it normal and it is swinging like this. Okay. Now let me also start increasing the mass. Okay, I'm increasing the mass to 1.5, right? We don't see that much. Now let me do one more thing. Let the gravity be moon. In moon, the same weight with that same kind of a speed that I did, it will move like this. Because the gravity of moon is almost 1/6 of, I think 1/5 or 1/6 of Earth. So in moon, it will be like this. Whereas if I change this to Earth, it will be like this. Now I change this to Jupiter. In Jupiter, because of the gravity, it is pulling a lot, the speed is increasing, right? So now what I'm going to do is, let us keep it on Earth. I'm going to stop the pendulum and let us do it once again. Okay, I am doing. Okay, now move. Right now, if there is no friction here, obviously the pendulum will keep on oscillating. This is like a jula, or we call it as lolakam, because it is moving here and there. It's like a swing. Now let me increase the friction. I keep increasing the friction. When I keep increasing the friction, you see here, let me do it once again. I stop here, I move it here. Now I keep it no friction. Just watch carefully. Let me move it in slow motion. It will be better. Now it is oscillating. Okay, it goes to that right extreme, left extreme. If there is no friction, that means no loss of energy. It will keep on moving, but it is not possible. Now I am increasing this friction. The friction may happen because of air, or it happens because here it will start slowing down. Keep watching. See, now it may not reach the leftmost point it was originally in, right? Now it has slowed down a little bit. In a few oscillations, it will start slowing down a lot. Now let me increase the friction furthermore. Look at here. Previously it came up to this point. Now it is coming only up to this point. 2 degrees are lost. Again, when it comes to the left hand side, it will come only to this point because it is losing the energy because of the friction. So this is the first part in pendulum. Okay. Now the same thing I am going to show you here. This is energy lab. Okay. In this energy lab, the same pendulum, I just clicked here. Okay. I just clicked here. What I do in this one, there is an energy meter here on the left hand side. If you see here, it marks Ke means kinetic energy, Pe means potential energy, E thermal is thermal energy, total. Let me show you. Okay, let me show you what it does. Okay, now I am going to make it oscillate once again. Okay, now it is oscillating. You could see kinetic energy and potential energy. When kinetic energy is, keep watching it, let me do it in slow motion. When kinetic energy is in peak, potential energy goes down. When it reaches this point, kinetic energy is peak. When this reaches this point, potential energy is. So you could see this. When one energy is more, the other energy goes down, but the total energy PE plus KE will become equal and standard. Now there is no thermal energy because thermal energy is not at all produced because there is no friction. Let me introduce friction here. The moment I start introducing friction here, just watch here in this meter. Kinetic energy and potential energy keep decreasing. Thermal energy is increasing because of the friction. The friction happens because the friction here, the friction on the board, the friction because of the air, the medium in which it is moving. So the thermal energy keeps going up and the potential energy and kinetic energy keep coming down. This is the fundamental model. This is why in our home also, when we have this pendulum clock, we will be putting in the covered, glass covered box. Otherwise, because of the air resistance, and when the air is moving or it is having some, even if you put the fan on, that will also affect the pendulum speed and the pendulum angle also will do. Another thing is the pendulum's length will also increase. I'm going to stop my screen. I'm coming back to video. Can anyone say in our home, in the pendulum clock, either it will gain time, the clock will go faster, or the clock will lose time? Can anyone tell me the reason for that? Why there is a time gain or time loss in our regular pendulum clock? Can you tell me? The kinetic energy it gets from the key. We have given the key and it has a spring inside, a metal spring inside, a metal roll actually. And the metal roll initially it is getting tightened, then it will start slowly releasing. Why it gains time? Because during summer, if the pendulum, because it is a metal rod, the length will slightly increase. During winter time or cold times, the length will slightly contract. Because of the change in length by even half a millimeter, it starts either losing the time or gaining the time. This is how you might have noticed in the old clocks, in the pendulum, there is a screw at the bottom to adjust the height by maybe 0.1 millimeter or 0.2 millimeters so that you can make sure the clock doesn't lose the time. So this is how it happens in our regular pendulums. Okay. This is the first experiment today I wanted to show to you in physics. Now, I am going to send you an aptitude question. Again, arithmetic or analytical reasoning. I have sent you the question now in the question and answers. 0, 2, 6, 12, 20. What is the next number? The reason again we are giving these tips or these as a small exercise to you also is that you in turn start giving this kind of exercise on a daily basis to the students, because almost every competitive exam is MCQ. You take any company in the college that comes for campus interview, they all conduct aptitude test. For aptitude test, this analytical reasoning we should develop. This is a fundamental. If a person develops aptitude, that person can learn any subject pretty faster. It's a mind tuning exercise. So 0, 2, 6, 12, 20, what is the next number? And can someone give the logic also on how you arrived at the next number? I will wait. Let us wait for the answers from people and then continue for the next experiment. Again, if someone wants to talk over the mic, you can also ask for send your name in the chat box to open your mic. We can also do that. We'll be happy to do that. What is the next number? There is a logic behind the sequence. Finding the sequence and finding the pattern is one of the most important thing in critical thinking and analytical thinking. I will wait for a minute and then I'll explain the question. What is the logic behind it? Anybody guess the next number? 0, 2, 6, 12, 20. What is the next number? There are two logics behind it. You can calculate this way. Initially, I start with 0, then 0 plus 2, then that number 2 plus 4, then 6 plus 6, then 12 plus 8. This is one logic, correct? Initially, I had the number 0. With that, I added 2. With that, I added 4. Then with that, I added 6. With that, I added 8. So what should be the next number? What should be the 30, correct? So next number I would say 12 plus 8 is 20. 20 plus 10, that will be 30, correct? That's one logic, correct? Now the same logic can be explained in a different way also. First number 0 is 0 equal to 1 square minus 1, right? 2 is equal to 2 square minus 2, correct? 3 or say 6 is equal to 3 square minus 3, correct? So each number is that number minus that number square minus that number. So this number is 5 square, 20 is 5 square minus 5. The next number is 6 square minus 6 is equal to 36 minus 6 is equal to 30. So this is the logic. This will look like a very simple logic for us. Whereas for a 7th kid or an 8th kid or even for the 12th kid, the mind has to be tuned on a continuous basis. And take it from me, analytical reasoning or even communication skills will not come over just one day or in a few classes. It takes time. It comes only by practice. Okay, that's the first thing. Now let me do one more thing. I'm going to take the next experiment. Okay, this is going to be in mathematics. Okay, let me copy the link. Just give me a second. So let me start sharing the screen. So I hope you are able to see the screen, right? Good. Now, to teach the slopes and the intercept, as we all know, this is a simple graph. We have this as the first quadrant, second quadrant, third quadrant, fourth quadrant. So first quadrant, you will have both positives. In this quadrant, X will be negative, Y will be positive. In these two quadrants, Y will be negative. Here X is negative, Y is negative. Here X is positive, Y is negative. Now, when we take a line, our equation is typically Y is equal to mx plus b or Y is equal to mx plus c, the way the textbook is talking about. But Y is a function of X. This m is the slope. This next number b or c, the way you use the convention, it is the intercept. Now, here, when I say mx and this c, this is this intercept. Now, I just make it 0. Make the intercept 0. That means it is going through the origin. This intercept is nothing but where it cuts the y-axis. I increase the intercept to 3. That means it is intercepting the y-axis at position 3. I increase it to 5. It is intercepting this y-axis at 5. If I decrease it to -2, it passes through this position. The quadrant here, the y-axis is negative. So this is nothing but where it intercepts the y-axis. The same thing we will be, as a typical mathematics teacher, we will be drawing a line on the board and then showing. Now, adjusting these numbers may or may not be possible in YouTube videos, whereas here it is possible. Now let me increase it to this. Then what is this slope? This m is nothing but slope. So how do I define slope? That this slope, again, this m, it is divided as the numerator and denominator. This is the distance in y-axis. This is the distance in x-axis. Mathematically, we will say delta y by delta x. What is delta y? Let me make this 0. That means this is 0. I have a point over here, or you move the point anywhere, right? You move the point, you are changing it. It is moving to 3 and 4. That means this is the point. Let us take this point. This is here, this is 0.3, 4, or say 4, 3. It is 3 units on y-axis, 4 units on x-axis. So the delta y by delta x is the slope. Now, rather than simply saying m, we are putting that also. Now let me put it as 4 by 4. That means higher the numerator, I am increasing the numerator. I am increasing the numerator, meaning I am increasing the y, delta y component. Just watch. If I keep increasing the numerator, like 7, 8, 9, something like that, this line comes closer to y-axis. So that when the delta y keeps increasing, this line slope comes closer to y-axis. It becomes more of vertical. It tilts towards the right angle. If I increase the denominator, if I increase the denominator, the more I increase, right, it comes closer to the x-axis, right? It comes closer to the x-axis. So the more you increase, then when it comes closer to x-axis, the line will become almost parallel. That means if x-axis component is not there, that means this line becomes identical to x-axis. So the slope is simply not just a number. We can define it as delta y by delta x. This is how we do. Again, to show different quadrant, they have also given something like, okay, if I put this line, another line over here, this is like a line crossing through this, y is equal to minus x. That means it is passing through this portion, this quadrant. You can also have different lines, and you can, for example, I move it here to tell the students, find out the coordinate here. In this quadrant, what will be the coordinate? The coordinate will look minus x minus y. In this quadrant, the coordinates will look like positive and negative. In this coordinate, it will be positive and positive. In this quadrant, it will be negative minus x plus y. So a very simple screen where you can show lines, slopes, intercepts, quadrants. I'm stopping my screen now. I'm coming back. Right now we have crossed the half time. I'm just conducting one poll. Let us take 1 minute to answer this poll. So far we have seen one simulation in physics, Pendulum, and other simulation in mathematics, and one aptitude question. I have just posted the poll to you. Feel free to answer the poll. Okay, I will just wait for 1 minute max, not more than that. Thanks for answering. So a lot of people already answered. It's good because we don't want to waste a lot of time, but just to get a feel from you all, because as I already said, this session is not to teach syllabus or subject to you. You are already an expert in the subject. How to use these sleek tools to make it easier and attractive to the students. That's all. Great. I could see. Let me stop the results over here, and I publish the results and I stop. And did you notice an interesting point? Let me, before going to the next point, if you see the results, 20 people answered, out of which 16 said yes very much, 20% said, 4 said okay, neutral. 80-20, this is called 80-20 principle. If you have time, you can search for 80-20 principle. That means 80% of your revenue, if you are a company, 80% of your revenue will come from 20% of your customers. You will spend 80% of your time with 20% of your relatives and friends. If you have 100 friends, and if you spend maybe say 16 hours, 20 hours in a week with friends and relatives, 80% will go to only 20% of such people. In some cases, it will be 85 and 15. In some cases, it will be 75 and 25. But when you do average across the world, it will fall into 80-20. This is a famous principle. There are a lot of papers published, surveys done. 80-20 principle. And it proved here. It proved right here in front of you. Okay. Now I stop this. Let us come back. Now let us do one more thing. Now let us take I'm going to share my screen once again. We will see in English. We will see one English exercise. Simple. We all know this regular and irregular verbs. Specifically, we have taken irregular verbs. Regular verbs meaning, let us take walk. The past tense will become walked. You add ed. Okay. Whereas when I say see, the past tense is saw. It is not seed. It is saw. So without either, I am not adding ed. In some cases, we see ied, carry, carried. We say instead of replace that y by I, carried, right? Typically, d, ied, ied. If you do that to arrive at the past tense, that is regular verb. Verb and the past tense, present tense and past tense forms are completely different. It is irregular verb. Now, just to teach irregular verbs and their past tense, make. What is the correct answer? Make is not correct. So I say made is the correct answer. Now the next question is take. It is not take, it is took. So if I mistakenly click here, it will say no, this is wrong, this is right. So it will also show you. So if buy, I say bought. Then think, thought. Wake up. Waked up is correct, wrong. If I wrongly click it, it will say no, it is wrong. This is the correct answer. Right? See, saw. I say can, it should be could. When I say drink, say drank. And I say fall, fell. Right? So this is a very simple exercise. What we can do is, again, we have taken 10 such verbs. There are a lot of verbs. Typically, if you are able to capture totally 300 verbs and 500 objects and 100 places, then pretty much you will be able to converse with anybody. This is a minimal set. There is a paper 300, 300, 300 or 300, 200, 100. If you have this combination, then you will be in any language, you will be able to converse with other people fluently, or you will be in a position to listen to them and understand them. Verbs are the key ones. Objects also in Telugu or in Tamil. For example, evaraina experiment chesara. So in this, experiment is an English word, right? Class lo demonstration chupinchara. So demonstration is a word in English. We knowingly or unknowingly use a lot of English words, a lot of Sanskrit words, a lot of Urdu words, a lot of Hindi words in our day-to-day conversation, right? Whereas the verbs, we definitely try to do it in our native mother tongue. So if we know 300 verbs and their different tense forms, pretty much we can understand that language, what people others are talking. So we will create simple exercises like this, and you can tell the people, do it again and again. Ask after you finish the class, maybe last 10 minutes, call people, students in a group 3 by 3 by 3 or 4 by 4 by 4. They have to answer these 10 questions as a must. Everyone should know the past tense of eat is ate. Again, to make it interesting, now look at this. Find the match. I am just same game. To make it interesting to the students, I am doing like this. Now countdown starts. Yeah, this goes like thing. Can comes. It comes in a different order. Now, what should I choose from the whole set of things that I am seeing is, so I should choose this one. So this is done. Then the bus moves or the train moves. Next station is Ongol. Think comes. For think, I should click here. Now the Vande Bharat Express moves. Next station is Nellore, right? Eat, ate. Now the train moves. Renegunta station has come. Drink, drank. So it's the same game, but the visualization is completely different. In one case, you are just clicking as a quiz. In another case, it is moving something like this, right? So you can change the game. Now you can also do like spin the wheel. This is also possible. Okay. I spin it. Now it is spinning, right? So drink. What should I say? I select drink. Now it shows the cards. Correct. Now I say drank. This goes, right? Again, the spin that appears from the spinning wheel. Now I spin it. Randomly, I choose can. So you can make it interesting to the kids. Same concept, but a different set of games. Make them play for 10 minutes so that they can understand. Right? This is on English. Now I am going to take one more thing in physics. Let us go back. I am loading this. You know, when the light passes through two different medium, this is one medium, this is another medium. Okay, this is air, this is air, this is water. The refractive index is different for air, it is different for water. Because of that, some amount of light is refracted, some amount of light is reflected. Both happen. So you see that. Now I say click. When I click this button, it's like a torchlight. The light is, this is the angle of incidence, this is the angle of reflection. When the light falls on the water surface, some amount of light is also reflected. Rest is refracted inside the water as a medium, because water is also either it is transparent or translucent depending upon the mixture or the color of the water. Suppose I can put blue ink in water. So now I have an intensity meter. Intensity meter is there. Now I'm saying when I put it here, it is 100%. When I come here inside water, after refraction, it is only 94.71% of that light is getting refracted. Now if I go back here, 5.29% is reflected. So the light has different properties. Now I can also show, I can take a protractor over here, right? Now you could see what is the angle of incidence, what is the angle of reflection, what is the angle of refraction. All these things we can measure, correct? So you can ask the students, now it is almost like this is 0 to this percentage, right? Now you can also measure. Now they have given the 0 right here. So it is almost 45. This is also 45. Whereas this angle is 30. Now just watch. Instead of water, I'm changing the medium as glass. When I change the glass, again, you could say water. I'm changing it to glass. You could slightly see, now again, if I put this is 100%, this is 90.81, this is 9.19. So the amount of light being refracted, the amount of light being reflected are different for air and water. Same way, the angle of refraction is also different because medium is different. Correct? So again, you can have different refractive index. You can move this in a different way. Accordingly, the refractive index will change. Right? If everything is air, then it will go straight. Now, the moment I keep changing this, right? Angle of reflection, angle of refraction, everything will keep changing. Correct? Now, the same experiment, this is on the regular medium. Just this is one medium, this is one medium. Now I take prism. If I take a prism, the prism can be in any shape. Typically, prism we will see pyramid shape, or it will have triangle in it. I can also have a trapezium. I can also have a square. I can have a globular prism. I can have a hemisphere. I can have a thing like this. Now, just imagine. I take a square, a cuboid kind of a thing, and I click here. The light goes straight. I move this, right? I move this. I tilt this, right? Because the angle of incidence is straight. When it hits straight, it goes straight like this. Whereas I tilt it like this. Then it is hitting here, it is moving like here. Now you could see that very clearly. The ray comes here, you could see a difference in this time. So I'm seeing from here. So the angle here is one refraction happening. Air to glass medium, refraction happens here. Here, glass, and it is escaping glass to air medium, the refraction happens again. So refraction 1, refraction 2. And the bending happens like this. Now I remove this, I take this, okay? I take a globe like this, okay? If I put a globe like this, oh sorry, the light goes through this also, incidentally, okay? Now it changes. It is refracted like this, it is refracted like this. In a globular or in a spherical model. I take a trapezium model. When I take a trapezium model, this angle is different, this angle is different. So if I tilt, then it changes a whole lot. Now when I move like this, you look at this, almost we have countered the angle of refraction here. So almost this ray looks like a straight line. Whereas when I put like this, there is one refraction happening, there is another refraction happening. Now I take this one, I take a regular triangular prism. Now you could see it is refracting here, it is refracting pretty close because the angle of incidence on this side is completely different. So we can show in a, and again, if you want to have a protractor, you can again measure all these angles, make people to do experiments in terms of angle of refraction on this end, angle of refraction on this end, so that what will be the total that is happening over here. So this is a simple experiment on the refraction side of light. This comes under optics. Okay. Now I am coming back to my screen. The last experiment I want to show to you today is this nuclear reaction. Okay. Let us see nuclear reaction. This is uranium-235 because this is the one that is suitable for fission, right? From this side, I am going to release a neutron and it is going to hit something. This in turn will release something and then the chain reaction will happen. This is a protective wall. Now watch, I click run, the neutron goes, it is hitting one and it releases something, it releases other neutrons, but that is not hitting other atoms because the concentration is very less. Now watch, I am going to increase the concentration. Enrich, right? I am increasing the concentration because for the given volume, we have got a lot of uranium-235 things over here. Now I run. It comes, it hits one, from there it moves, then that releases a few more atoms. Now I am increasing some more. Now I run. Now watch. It is releasing, it is hitting some other atoms, then they are also releasing atoms. Still, it is not looking like atom bomb. Now I am increasing. A lot more U-235 stuff is here for a given volume. Now I run. Watch. See, one releases some neutron and that neutron hits other set of things and that hits. This is really like an atom bomb, right? It never stops unless it finds space to stop. It doesn't stop. Now it stopped because the released particles are not able to hit. Now watch. Now this is like a real atom bomb. Now watch. So many particles are released and they in turn hit the other ones and they in turn hits the other ones. So this is an explosion. This is an explosion and this explosion makes everything. Finally, there is only one atom left over here. Rest everything is completely done, right? This is the fundamental principle of what happens in a atom bomb, in a nuclear chain reaction, right? I am stopping my screen. With that, I come back to the video. So we have seen 5 stuff today, 3 in science, 1 in mathematics and 1 in English. I want to hear from you. How did you like? Before I want to post one more. Okay, I'm going to do one thing. I am going to copy this link. Anyway, these links will be made available to you. I'm copying this nuclear reaction link. You can check in your thing how it runs. I just copied the link on your Q&A box. What I will do is, in fact, I will copy the as on date, all the things that I have noted here. I will publish this to you. I will send it through WhatsApp groups. You can use it. You can show to kills. I have copied the nuclear reaction URL here in the Q&A chat. You can also try. Are you able to see the nuclear reaction? Anybody? Because we also want you to try on your machine. It may work on my PC. You may have some compatibility issue on your PC or your browser. But if you use Chrome or a Safari browser, I don't think there should be any problem. Or even Internet Explorer, not a problem. Edge, Microsoft Edge is fine. Firefox is also fine. Right? You can try that. I will wait for a minute. You can give your reactions. Your reaction on the chain reaction. All right? See, this one simulation will solve a lot of doubts for the kids. How it releases, how it hits, how it becomes the explosion, unless you attain critical mass. Till you attain critical mass, it will not be a chain reaction. So how it attains critical mass, that also you can show. So that is why we use a lot of simulation even in colleges for most of our explanations. Anybody tried? For anybody it worked? You can, oh, okay. I could see a few hands raised. Anybody wants to talk? Anybody wants to talk? You can type your name in the chat box. We can also unmute your mic. We'll be happy. Okay. Now, before I close the session, I want to post one more question. Okay. You should not use calculator. You need to find a way. Okay. I am sending you a multiplication problem. 106 into 94. How will you find the answer? Are you going to do the conventional way, 4 into 106 and then 9 into 106, then add? Is there any shortcut? Can anyone come with a novel idea of 106 star 94? Is there a way, better way, based on our mathematics principles that we know, to find out the answer? The question is very simple. 106 into 94. Conventionally, we can do multiplication, no problem. Is there a simpler way? Anybody? Don't use calculator. You can tell me what is the simplest way that to solve this problem. Yes, perfect. I think we could get Vaniji. I could say that is the right answer. So 106 is 100 plus 6. 100 plus 6 multiplied by 100 minus 6. You know it is nothing but a square minus b square. So 100 square minus 6 square. In a few seconds, you can solve the problem. But only thing is, we should get that comprehension first. This comes only by practice. It comes only by practice, right? So by seeing the problem itself, is there a way to simplify it? That we need to start looking at it. Okay. Now I'm putting the second poll. Do you find today's class interesting? Okay. I put that poll. Again, you can answer. I will wait to hear till it crosses 20 now. Okay, good. Well, again, in this case, you could see 92%, 8%. Still, it will be almost like everywhere you could see in some cases, it will be tilting towards 90, 10. In some cases, it will be 70-30, but it will always oscillate. Anything on a large sample set, it will always lean towards 80-20 principle. Okay. I published the result. Now you could see that 92% yes, 8% okay. Okay. Hide. Okay. Now with that, I will close the session today. Hope you enjoyed. Do you want to convey anything through chat? If you want to convey anything through chat, I am open. Or if you want to talk, I am open. You can let us know. If you want to talk, you can say open mics in the chat box. We will open the mic for you. Cool. So thanks a lot. I will close this session here now. Thanks for attending this class. Hope it is useful. Every day the links are passed along with the topics in the respective WhatsApp groups. You can collect that. We will finally send a document also at the end of this month. With that, we formally close this session. Thank you. Jai Hind.